In this video, I'm going to review some solving that will be coming up regularly in Chapter 4. And while I'm not going to be able to cover every type of solving you're going to run into, this is a good start to get you back on the track, remembering some of the techniques that you may have forgotten since you learned them back in pre-calculus. So the first thing would be solving something like a cubic or a higher order function where grouping or other such methods doesn't work, where you have to look at it and you say, I just don't really remember. So there was an idea called the rational roots theorem where you would take the constant term and all the different factors of the constant term divided by all the factors of the leading coefficient. But in calculus, we're going to look for something a little more efficient. And so we love when you guys use calculators to help you, but not to stop learning. So the idea here is I've already gone through. I already put in my y equals line. I've already put in this function here. And for my window, I just did a standard scale of -10 to 10. So I just simply did a zoom 6 for standard. And that gives us the graph that came up just a second ago. There we go. And what I'm looking for, if I'm trying to factor, I mean, the whole purpose of this, of solving, is I'm saying I'm trying to factor this out because my function's already equal to 0. If it's not equal to 0, I have to make it equal to 0. Get everything over to the right-hand side or to the left-hand side. It doesn't matter. Just a side. And we need to figure out what makes my function 0. And so that graph that just came up, I've actually already cheated and made it big right here. And what we're going to do is just look for hints. We're going to look for something we think might be a 0, and we're going to give it a try using synthetic division. So you will see here, it looks like my graph may pass through -3. So I'm going to go ahead and try synthetic division using the value of -3. So of course, we're going to start with our leading coefficients. And remember, if one of your coefficients is missing, meaning there is no x term, it just would be like that, then you would have to fill it in with a 0. Now, thank goodness, we actually have that term, so it's kind of simple here. And synthetic division says we just write our coefficients, we bring down our first one, the outer numbers multiply, giving a -6, they add together to make +5. And so the inside numbers add. Outside numbers multiply make -15. Inside other numbers add to make -3. -3 times -3 makes +9. Those add to make 0. And we hopefully remember from the remainder theorem, which says when I substitute in this value, the remainder is the y value I get out of the function. So therefore, what this is saying is if I substitute in -3, I get out 0. That means that yes, we did interpret this correctly. When I substitute in -3, I do in fact get out 0, which means that is a factor. So therefore, we can now rewrite this function as my x plus 3, because when I substitute in -3 into here, this should be a -3 plus 3 should make 0, because the remaining terms here would be reduced by the degree of 1. So that'd be 2x squared plus 5x minus 3. There we go. When I substitute -3, it should make this factor 0, because then no matter what happens over in the other part of the factor, it doesn't matter, because 0 times anything makes 0, therefore it's a true statement. Yay, we're happy. All right, now we continue factoring. Now, because this is quadratic, we can use any technique we've ever learned in the past. I'm going to go for a little guess and check and see how that goes for me. Let's see if we can factor. Of course, we could do synthetic division again. We could look at the graph and see if we can find a 0. But let's see what we see. I know my numbers have to multiply to make -3, and there's only 2 options for that. And I know my numbers have to multiply to make +2, and there's only 1 option for that. It's a 2 and a 1. So we're just either thinking, does the 3 go here and the 1 go there? Or vice versa. Does the 3 go here and the 1 go there? Well, what I'm going to say is, to me, I think the 3 is going to go on the right-hand side, the 1 is going to go on the left-hand side, because the 2 times 3 is going to make 6, and then 1 times x is going to make 1. And so if I can get those to subtract, I need the 6 to be positive and the 1 to be negative to make a +5 for my middle term. So what that says to me, I think we got this, is I'm going to do a, whoops, let me use red, +3 and a -1 there. Because 2x times 3 makes +6x, -1 times x makes a -1x. Those would add together to make 5x. So we are perfect. So therefore, I look like I am factored. So now, what are my solutions? My solutions would be x plus 3 equals 0, right? You take each factor, set it equal to 0, and then solve each one individually. Now, a lot of times students, this is our next problem. I'm going to scoot it down, give myself a little more space. Sometimes students have that algorithm memorized, but they don't really understand why. So take a second and think about what we're saying. It's what I just described above, that each individual factor, if we can make that individual factor 0, then 0 times any of the other factors makes the whole thing 0 and gives us a true statement of 0 equaling 0. That's going to become important as our functions get more difficult. We're going to start factoring out exponentials and logs, but it still holds that same idea as if everything is separated by multiplication, if everything is factored, then you just take each individual factor, set them equal to 0, solve for x, and you will get all of your answers. Now, let's go ahead and check, right? So I've solved. I know x equals -3 with a multiplicity of 2, and I have x equals 1/2. Fantastic. How can we check? Well, I highly recommend make sure you didn't make a slight mistake. Again, another good use for the calculator. I have my calculator in the table set to independent variable to ask. So now when I go to my table, and remember, we still have our y1 typed in. It's still the same function. So when I go here, if I type in -3, my answer should be 0. Look at that, it is. And when I substitute in 1/2, and I can actually type in 1 divided by 2, my answer should be 0. Let me make that a little bigger for you. So you can see when I substitute those values, I got out 0. That's great news. Okay, so remember, factoring higher order polynomials, synthetic division, use your graphing calculator to help you. It's going to be super helpful. Okay, so for this problem, it's 0 equals x to the -1/2 minus x to the -3/2. Okay, for this problem, a lot of times we can get thrown off by the negative exponents, and especially how to interpret our answers at the end. So let's go ahead and work through this problem. Now, the suggestion I have for students is always factor out the variable with the largest negative exponent, so meaning the most negative, the biggest negative number. So in this case, that'd be -3/2. And when we distribute that back through, when we factor it, we should be able to distribute back through and get what we started with. So you'll see one of the reasons why I like doing that is because if this distributes back through to that 1, it gives us back what we started with. Kind of simple. All right, so we're going to go ahead and do that. Now, that leaves me with the other term. And I have to say, if I were to distribute this through, it's got to give me back the x to the -1/2. So what would the exponent on this x be? Well, remember your rules. What we're saying here is x to the -3/2 times x to the what makes x to the -1/2. And well, how our rules work, I mean, x times x is x squared, because when you have the same base, your exponents add. So if you can't see it straight off the top of your head, write a little algebra problem. What we're saying here is -3/2 plus what equals -1/2. Solve for x. So I add that 3/2 across. So that's going to give me -1/2 plus 3/2. That's going to add together to give me 2/2, which is equal to 1. So therefore, this exponent is simply, 1. And we obviously don't write the 1. But there we go. We have factored. So now we don't worry that this is a -3/2 anymore because it's factored. And remember, like we talked about in the last problem, is we take each of our factors and set them equal to 0. Now we ask ourselves, what do I do with this x to the -3/2? Don't overthink it. Just go back to meaning. A negative exponent is repeated division, just like a positive exponent is repeated multiplication. And so therefore, repeated division means it's going to be 1 divided by this value. And I want you to stop and think to yourself, x, what number can I substitute in for x that's going to make this 0? Not 0, because 1 divided by 0 is undefined, right? So can I substitute anything in? No, because for us to get a fraction that's equal to 0, we have to have 0 over a number, right? And I have a 1. That's not changing. There's no variable there. So therefore, what solutions do I get from this x to the -3/2 equals 0? What do I get from 1 over x to the 3/2 equals 0? Yeah, none. Right? There's no solutions that come from that, but that's okay because I have another factor to work with. X minus 1 equals 0, so I set that equal to 0. I add 1 across, so I get x equals 1. Fantastic. So now let's go back and verify, does that actually work? If I take this value and substitute it back into the original problem, I get 0 equals 1 to the negative 1 half. But what I'm going to do is I'm going to rewrite that just with positive exponents, um, just to make it a little simpler for us to kind of think about. So that's going to be 1 over the square root of 1 minus 1 over the square root of 1 cubed. And hopefully we can fly through this pretty fast. And we say, okay, square root of 1 is 1. So 1 divided by 1 is 1. Minus square root of 1 is 1. Cubed is 1. So 1 over 1 is 1. And hey, look at that. Look at that. And I'll put a little question mark saying, is this true? And as we just discovered, 0 equals 0. Yay, it's true. So therefore, our solution is x equals 1. So just as a reminder, we need to be able to factor variables with negative exponents and fractional exponents. It's not hard. Just factor out the most negative exponent, or you could factor out the fractional part. And you're going to play this little game where you just set up the equation and say, what would my exponents now be? And you'll get there. Okay, last but not least, trig. Trig. And boy, did I try to pick a doozy for you just to really help you remember. Now, one thing, just as a warning, we love to hide this sine squared on you. I don't have to start off with that. I could, for example, we all know, hopefully, sine squared plus cosine squared equals 1. So if I wanted to, I could start the problem this way. I could have 0 equals 10 times 1 minus cosine squared x minus 3 sine x minus 1. Or I could even have this 10 distributed through, which would give us 10 minus 10 cosine squared x minus 3 sine x minus 1. So one hint to you is always get your function you're trying to solve in the same trigonometric function. If you have sines and cosines mixed, look for something that's squared and say, hey, I'm going to use my one of my trig properties. I'm going to use my Pythagorean identity to get myself from cosine squareds into sine squareds. Okay, so pretending we went backwards, we got back up here to what we have written in black. All right, so now we have this function. Just as a reminder, be on the lookout for things that are quadratic in form or things that we know how to factor. Some of you wouldn't even have to switch this. You would just recognize I have a term with a sine squared. Then I have a term with sine to the first. Then I have a term with no sines. Now, if it helps you, you can say let u be sine of x. Because if I do that, then this is the equivalent of 10u squared minus 3u minus 1. And now you just say to yourself, do I know how to solve this problem? And if you do, you say, oh, I can factor this. 10, well, let's do a little guess and check, see what we come up with. I know it's got to be a u and a u. Now my n term is easy. It's a 1 and a 1. Got to be. So we need two values to multiply in front of my u's, some numbers, that when I multiply them against the ones, they're going to be that number, but then they're going to add to make negative 3. So let's see. Well, 10 and 1 does not seem like it's going to work because that would not give me things that would add to make a negative 3. But how about a 2 and a 5? Hey, so therefore, if I need a negative 3, that means my 5 needs to be negative. So when I distribute it through, that needs to be a negative, which means the other one needs to be a positive. So now we are going to be able to solve this. And we take each factor set equal to 0, and I get 2u minus 1 is equal to 0, and I get 5u plus 1 is equal to 0. So now, when I go ahead and solve that, what are we going to get? U equals 1/2, and u equals negative 1/5. Fantastic. Am I done? Put a box around it? No, we did not start with u, right? We started with sine. So that means everywhere we have a u, we need to go ahead and sub back in a sine. So we know sine x is equal to 1/2, and we know sine x is equal to negative 1/5. 1/5. Now, here's what I want you to be able to recognize. We're not done. We need to actually solve. So how do we solve for sine? Well, we do inverse sine of both sides, right? We do arc sine. So that's going to leave me with x on the left-hand side and arc sine of 1/2 on the right-hand side. And similarly, we're going to get x equals arc sine of -1/5. Now, you need to understand when it's okay to leave your answer just like this and when you're supposed to actually be able to simplify. Now, these two triangles that you may be a little familiar with, the 30, 60, and 90 triangle, which is a 1 rad 3, 2, or the 45, 45, 90 triangle. And of course, we could do these in radians as well. There we go. These ratios need to be jumping out at us. So you need to recognize, you need to look at this and say, is there anything, any triangle that has a ratio of a 1/2? Oh, yes, yes, yes. I can get that out of my 30, 60, 90. So, therefore, x is equal to, because remember, arctrig takes inside ratios and gives out angles. So therefore, which angle am I looking at? If my sine is the opposite over the hypotenuse, then that means the opposite of 30 would be 1, and then the hypotenuse would be 2. So therefore, I'm looking at a 30-degree angle. But in calculus, we don't write our answers in 30-degree angles. So that would be what? Pi over 6, right? So therefore, my answer is pi 6. Now what about on the other side? What do I do with this? Is there any ratio that we're supposed to know that has a 5 in it? No. So that's your answer. Leave it. Unless WebAssign or unless your professor says to round to some specified number of decimal places, you're done. That's your answer. Now, of course, be cognizant of quadrants and where your answer may be in the different quadrants. But do not try and just jump straight to the calculator and get an answer. That is not what we're looking for. Okay, we want you to leave it exact. Alrighty, well, I hope this gets you started on your solving, and we'll see you in chapter 4.